Assalamualaikum and good morning. My name is Muhammad Fakrul Fahmi bin Ismail. Today I will explain about welding joint geometry in course code BMMK 1054 welding document. This is a member of my group. For introduction, the anatomy of a weld is the structure of the weld itself, described in terms of weld, leg, toes, throat, and face. Each part not only contributes to the integrity of the weld, but also has an impact on other factors in the welding operation. Joint geometry is similar but refers to the dimension of the weld joint itself as opposed to the complete weld. Next, I will explain about the type of groove. Welding groove. A groove weld is an attachment between two joints elements that enable space for the metal to be contained. After the fillet weld, groove welds are the most used weld. A groove weld might be one of 7 different varieties. The first is a square groove weld. The square groove is a bar weld joint with the two pieces being flat and parallel to each other. This is the V-shaped groove. Square groove weld. Second is a single V groove weld. A groove weld will be used when two parts come together in the same plane. This weld will be applied in a butt joints and may have a preparation or not before welding. In this picture, it has V-shaped groove. The third is a single bevel groove weld. Only one half of a V groove, this dimension, is shown within the weld symbols itself. There is not always a rod opening, and this dimension can be omitted from the weld symbol. Only one part of the workpiece is angled 35 degrees. Here we can see the difference between this picture, these two type of diagrams. This one, there's no root face. This one has a root face, and this one has a root face. Fourth, single V half groove. It is the same as a single V groove, but only half of the groove is made. It has no root face, no reinforcement, and no root opening. See? So you can see there is no root face, no reinforcement, and no root opening. The fifth is single V groove weld with backing. It has a similarity with a single V groove, only it has additional backing on the root face. Backing is defined as a material placed at the root of a weld joint for the purpose of supporting molten weld metal. Temporary backing may be made from copper or a ceramic substance that do not become fused to the root and easily removed when welding is finished. As you can see, this is a backing down there. It's backing. Same like V groove, but it's additional backing. The sixth is single V groove with no root face. It's a diagram for the no root face. 7. Single J groove weld. Single J groove weld are when one piece of the weld is in the shape of the A of a J that easily accepts filler material, and the other piece is square. A J groove is formed either with special cutting machinery or by grinding the joint edge into the form of a J. Only one part is made into the letter of a J. As you can see there, only one part. 8. Single U groove weld. Single U groove weld are when one piece of the weld is in the shape of U that easily accepts filler material and the other piece is square. The workpiece is made groove into a U shape. 9. Flare V weld. Commonly used to join a round or curved piece to a flat piece. As with the flare weld, the dip of the groove formed by the two curved surfaces, the intended dip of the weld itself are given to the left of the symbol within the weld dip shown in parents. As you can see, here is the dip of the groove formed by the two curved surfaces.
That's all the information from me about the type of groove. I will leave it to Daniel to continue the next slide. Thank you.
Assalamualaikum and good morning. Let me introduce myself first. My name is Muhammad Linal Iman bin Muhammad Sabri from 1 BMMK. Today I will explain a little about the topic 3.3 and 3.4, which are notation detail, information, and consideration weld geometry. This drawing shows you a single V groove with backing. This is a face reinforcement. This is a fusion zone. This is a heat effectance zone. HZAC. This is a root face. And this is a backing. And this is a root opening. This is a through thickness. Show you a 9 mm. This is a 2 of weld. This is a weld face 30 to 35 angle. And this is a weld zone. This is a weld zone 60 to 70 angle. The second drawing show you a fillet joint. This is a fusion zone. And this is a through thickness. And this is a root. And this is a leg. And this is a HZAC, heat effectance zone. This is a fusion face. This is a weld metal. And this is a weld zone. And this is a toe. Detailed information. Number 1. Weld toe. The toes of the welding are essentially the edge of the point of the hypotenuse. Weld face. The face of the weld is the outer visual or hypotenuse that you see when looking at a fillet weld. Number 3. Weld root. It controls how deep the weld penetrate and how well it diffuse to form a steady junction. The concave side of the weld focus point is this. Number 4. Leg. The distance from the joint root to the toe of the weld. Number 5. Fusion zone. After an object has been welded, a fusion zone is a piece of material that remains. The chemical composition of a fusion zone is a mixture of the substrate being welded together and any additional filler material that may have been employed, and it begins and ends. Number 6. Face reinforcement. Weld reinforcement on the side of the joint from which welding was done. Number 7. Weld zone. Zone contain the weld metal and the HZAC. Number 8 is a throat thickness. The space between the center of the face and the throat of the weld is known as the throat of the weld. The throat should typically be at least as deep as the thickness of the metal you are welding. Number 9. Root opening. A separation at the joint between the workpiece. Number 10. Thickness. It tells us how thick the plate is compared to the base metal. And then lastly is a backing. Backing is defined as material placed at the root of a weld joint for the purpose of supporting molten weld metal. This is a 3.3. Consideration weld geometry. Consideration weld geometry. Number 1. Butt, corner, edge, lap, and T-joint are some of the type of joint that can be used in weld sheet metal design. Type of joint and type of weld are typically distinct. However, the two names are frequently confused in reality. Number 2. Fillet, square, and groove weld are the three most common welding. Number 3. No fillet metal is required for a butt joint constructed on a short flank edge, which help control melt through and distortion. Number 4. A lap junction with a double fillet weld should have a minimum overlap of 1 in 20 mm, 35 mm. When loose strength is necessary, a single fillet and a shorter overlap may be sufficient.
That's all for my topic, annotation, detailed information, and consideration weld geometry. Rizal, please continue. Thank you.
4.0 Head Effected Zone. What is the head effected zone? The method acts of the head generator during metal cutting or welding. Because metal is a good head conductor, the head is transferred away from the cutting edge through the metal body. The head effective zone is generated between the melted metal and the unified base metal. The metal is not melted in this zone, but the head has caused alteration in the metal microstructure. Effect of the head effective zone. The head effective zone lead to structural change in the metal that weaken the part in this area. A metal mechanical properties such as fatigue, resistance, distraction, and surface cracking are affected. 1. Metallurgical chemical change. What is metallurgical chemical change? When cutting metal, the metal absorbs heat at a rapid rate. The cooling effect is also immediate change. 2. Surface nitriding. Surface nitriding include adding nitrogen to a metal surface and improve its hardness. 3. Oxidation. When metals are exposed to high temperature, they can oxidize and undergo other processes. 4. Phase change. When exposed to high temperature, for example, of stainless steel will change to metallic steel. 5. Hydrogen embrittlement. High temperature can lead to hydrogen embrittlement. Phase transformation may occur in some metal due to this atomic hydrogen. 6. Corrosion. Intergranular corrosion occurs because of the lack of preservation. Okay. Level of the head affected zone. What does the color tell? A rest of teeth are found in the husk because of using various temperature throughout manufacturing operation in order of increase temperature. These teeth vary from light yellow to dark blue. The best color in order for temperature program are factor the further affect the formation of this head tint are: first, surface condition. Rugged surface oxides face procedure more prone coloration. Second, surface contamination. Impurities like rust, paint and oil also affect the tint. Third, oxygen availability. As limited access to oxygen reduce oxidation. Fourth, chromium contents. Chromium increase oxidation resistance. And last, 5.0 conclusion. We as a group were assigned to do a welding joint geometry project. In the implementation of the project, we have acquired a wide range of knowledge in welding joint geometry. We are also able to indicate the type of design and drawing symbol in the classification are requirement according to the relevant standard. In addition, we were also able to apply work-based learning by going to and demonstrating all relevant documentation from various standards on welding joint geometry. Next, we can find out about the type of groove. There are 7 basic types related to the type of groove evaluation.
That's all from us about welding geometry. Thank you.